not here. I mean, he's presenting.
That's right.
Yeah, I'm presenting remotely.
Hi.
Okay, hi.
What time is it there, Nate?
7:30, but I had
Not too bad.
I had an int area at 2:30.
Yeah, it's pretty early for Greg. It's
Oh, that's true.
5:30 for you, Greg. I got my home time zone on my computer here.
Oh, that's right. Me too. Except, yeah.
Yeah, it's kind of funny having this multicast discussion and starting about the benefits of dense mode.
That's hilarious. Coming back around.
Yeah.
Now that would be quite a
Please no. Please just don't let that happen. Please.
I'm going to push for it to happen, just to piss people off.
Can go back and read your draft about lessons learned.
Yeah, that's right. Turns out that it's actually the optimal thing for large language models.
No, it isn't. It's an artifact of creating a layer 2 overlay on top of a layer 3 network. It has nothing to do with replication.
Should we get started?
Yeah. People would come in. We get it. Now we can start.
Okay. Yeah, let's start now.
So you.
Steve is here. Yeah. Okay. Yeah. Welcome to PIM. Next slide. If you do that. This is the notebell. Hope you all have seen this before. Yeah, you should go and look this up if you haven't seen it before, but it's more or less how we are supposed to behave when we are in the IETF. Okay, this is the agenda. It's quite a full agenda. So, yeah, any comments on the agenda? I think, Torles, you were asking if you could be moved up a little, or yeah. Yeah, I think we'll just go to the next slide. So since last IETF, we actually published several RFCs. So all the work we did revising IGMP version 3 and MLE version 2, progressing them to internet standard has been done. So thanks a lot to Brian for that. Also, the new RFCs, it's kind of cool how the IGMP 3 ends in 76 still, and it's also standard 100, which is even better.
Yeah, so I don't know if you folks have probably all seen we're reaching IETF 10,000, but most people ignore that the real IETF process, all the pain is to get the work up to a full standard. And well, luckily, you know, it got IGMP v3. And so I thought there was time to actually memorize that. So I got some mugs done. And there's one special mug with a name on it.
Yeah, Brian.
And you know, this is a group effort. There is a mug for everybody in the back of the room. So maybe at the end of the no, they don't have. That's just the one special one. that's a special one. But yeah, please, everybody pick up a mug from the back at the end of the meeting. I'll need to quickly, that's why I wanted to go over to Core next door, but I'll be back and we can deal with the mugs at the end.
Yeah.
Thanks.
All right, great. Yeah, thanks. Awesome. All right. Yeah, so we also got standard 101 and the 3228 biz related to that. The IANA considerations is BCP 57. We got the 1112 biz that Torles is working on. That should be nearly done or pretty much ready for publication, I guess. We'll talk a bit about that soon. Also, some other drafts, DR improvement. We'll see if we can pick that work up. BDR will be discussed this meeting. Let's see. Also, other drafts, multi-point policies and IETF last call. Maybe it just ended, I'm not sure. Policy PIM requested publication for that. Some John Prune attributes for Lisp got published, RFC 9798. The MOFR draft is in RFC editor's queue. So lots of progress here. Our AD has been very busy. And we got some Yang drafts that are not discussed this meeting. And also lessons learned is not discussed today. And last slide. Yeah, I wrote here that gap and stuff are not discussed today, but they will actually be covered together with the problem statement by Nate soon. Let's see. Yeah, the multipath work, Hitoshi is on the agenda. I'll talk about the forwarding enhancements, PFM, and the deterministic hashing is not on the agenda. So that's the status. Any comments? Questions?
Yeah, real quick. I think the gap up through the 0conf, so the first four are going to be discussed all under the auspices of the problem statement one.
Right. Yeah. Okay. Yeah. Thanks. Okay. Then I guess we're ready for the first presenter, Torles.
All right. So I thought we were done last time. So then Stick brought up, next slide. Oh, wait a second, that's me. One question about that permanently joining, which I couldn't figure out a good reason. So I went back and then unfortunately I stumbled across something, which you should never stumble across things, but that one was too important to ignore. And that is, oh my goodness, I don't know. Okay. So I should really upload PDFs. Okay, you persuaded me. There is RFC 1112, which is the still valid standard for IPv4 host requirements. And that one actually says in section 337 in summary that all hosts should support IP Multicast, but may support IGMP. Having actually the explanation that you really don't need IGMP. Nobody needs IGMP. Multicast is link local. They didn't say it, but that works perfectly fine without IGMP, which is true, and which, for example, let's say, was perfectly used, and I think is still used 40 years later before Dino implemented IP multicast routing in iOS, right? So there are, devices that perfectly run link local scope multicast for OSPF and other groups without any IGMP, but RFC 1112 doesn't have even that option, right? It has layer 0, 1, and 2, and layer 2 says multicast sending and receiving with IGMP. So I thought long and hard. So I added layer 2L, which basically says it's sending and receiving, but really without IGMP and should only be used for link local scope multicast. And then basically the point, of course, is now that IGMP v3 is a full standard. We also start having a requirement in the document that says you should support multicast layer 2, and only if you cannot support layer 2, then you should support layer 2L. So that's basically exactly what 11.12 says, except that it's upgrading the IGMP requirement also to a should. I cannot come up with a must. If the group feels we could add the must and upgrade that, that is fine. I just was trying to be as backward compatible as possible. And for V4, I cannot find a justification for a must. Right? Just because we're multicast fans, we want to go back to the ISG and say this is actually more compatible with 40 years of deployment now than 11.12 was. So that's why it immediately goes back to full standard, and a must may be a hindrance to that. So that's the V4 change. And I brought this up to the mailing list when I had it. So of course, Brian seemed to have done exactly the same check for V6. Oh, I was already talking about that. And click, next slide. No, go on. Where? Huh? Okay. Oh, that was V6. Yeah, sorry, wrong order, right? So Brian was pointing to 4291, which I was I had read that, but I hadn't really kind of taken the interpretation that that Brian correctly did, which really that because base requirements for IPv6 address management does require link local multicast, you also must have multicast. So now we have the requirement in there, you must do multicast, right? But of course it should be level 2, and if not, then it must be level 2L. Right, so because for all the stuff that V6 host requirements require, it's link local scope, so it could also be done without any MLD. But of course, it should be level 2 with MLD. Right, so basically, last IETF we didn't have an RFC with this one that was requiring any multicast. Now we have a should multicast V4 and V6, and even must V6 with even if you're not using MLD, right? So I hope there is very little evidence that there are any devices that are doing V6 with MLD support. I wasn't there in the early days that much. I think Stig might remember even more. I can't remember the first implementation of V6 multicast or V6 IPv6 in iOS or others. Right, so we may want to go back and revisit that in detail, but basically this sounds like a sane place to do. And then the final one, and that was Stig's asked, so I put that back, have a new section trying to explain that. I went into the Linux kernel, other places to try to figure out how that 224001 is being handled, and indeed it seems to be still statically joined. I couldn't find any really good use case for that. The only technical reason which I added to the explanatory section is that it allows you to avoid kernel level APIs for joining that group for some of the things you may do over that group, right? And I do see that in the Linux kernel as well. So that was the only justification. But in the end, the main justification is it doesn't serve any useful purpose, but we have had this requirements in there since '89. Doesn't seem to have hurt anybody, so we're keeping it. That makes us happy with the ISG again. And that's it, folks.
Yes, Stig here. One thing that maybe bothers me slightly is that I think the MLD RFC says that it's required to send reports for link local because of snooping devices, whatever.
That's true. And I'm saying level 2L is there is, if you cannot do level 2, right, for whatever reason, right? So I was trying to make it as compatible with everything that's out there as possible, right? So, and the 4291, I cannot translate myself into you must do MLD, because you can do all the link local scope that are required by 4292. Those are all link local scope IPv6 addresses. They will work perfectly well without any MLD implementation, right? So that's why the suggestion to say you should do level 2, and level 2 says you must do MLD. Right, and if you cannot do that, then you'll do level 2L, which is you can only do link local, and that's your only way to not do MLD. Right. But MLD is not changing. MLD must do signaling for link local, so that's not changing.
But you have to hope that there's no snooping switches that require
exactly. Yes,
reports.
Yes. But then, of course, the link local without IGMP or MLD doesn't work, because we explicitly put into also the IGMP and MLD snooping. We put the you must do snooping for link local in V6. Yeah. So yeah.
Okay. Yeah. Thanks. Yeah. So you believe that it's ready for publication now, or?
As much as I thought so last time, but
Yeah.
I think this change really was good and useful, because now we
Yeah.
have the two V4 and V6 host requirements, I think, well embedded. We have upgraded multicast to now a should and a must, which was hidden in some other RFCs in the past. So it was
Yeah.
good that we did this one more round. But yes, of course, I think it's ready.
Yeah.
But we'll still have ISG review, right? So from that perspective, the question is, do we still feel that in the working group there is still anything we can do to significantly improve it?
Right.
And I don't think there is.
Yeah. So yeah. So I think we should do a working group last call just to give people, some deadline for giving comments if they have any. But if we don't get any comments, then I think we are probably good. But yeah, also want to review it myself again. But yeah, okay, thanks. Okay, I think I'm next on the agenda. Yeah. Yeah, so this is a draft I presented a few times before. Because I skipped a couple of IETFs. Wanted to do some implementation work before I came back here again. Just to repeat what this is for people that haven't seen it before. So we have this mechanism called PFM, where we can flood information in a PIM domain about active sources. The way it's defined today is you have an S, G TLV for a flow. But the problem is that it's very hard to add any additional data to that. The obvious way of doing it is to have sub-TLVs, but the way it's defined today, you can't really do that. So this is defining a new TLV that explicitly can have sub-TLVs. The other part, which is what I've been working on, is this reduction in message forwarding. So yeah, I kind of said this part already. I don't know if it's obvious, but if you have one TLV with source and group, and you have multiple TLVs with different sources and groups, you can't easily add a separate TLV, and which only applies to one of those S, Gs, because you don't know which one applies to what kind of. That's why I want to use sub TLVs. I'll skip this, but it's in the slides if anyone wants to look at it. For the forwarding optimization, I know I talked about this before too, but yeah, the basic idea is if you have multiple links between two routers, there's no point in sending the same message multiple times on multiple interfaces. So if you look on the left side here, without optimization, if there's like 3 links between A and B, then router A sends its message out all interfaces. It's like BSR forwarding. It will be sent 3 times to router B. But B only accepts it on the RPF interface, so it will only really use one of those copies. But A has no idea which interface would be the RPF interface. The other part is that you also, when B receives it, it forwards it out all interfaces, so it will go back to A on multiple interfaces. Instead, what we do with the optimization is A sends it on one interface, B does some kind of loose RPF check. So it says, it's maybe not on a right point-to-point link, but at least I received it from A on a point-to-point link, and the actual RPF interface should be from A on a different point-to-point link, so I choose to accept it. And also it knows that it should not have to send it back to A. And I use PIM hellos with a router ID option to control this, so it knows that it's the identity of the router A. So in the last revision, I've implemented this and added more details how to do this. So let's see, do I have a slide on that? Okay, so we have the RFC 6395 that we use for the router IDs. But then the thing is, let me go back to this. We only want to do this between A and B for point-to-point links. So there is some work checking which neighbors do you have on which interfaces, and is B like the sole neighbor on these interfaces or not. And there's some text in the draft now that explains a bit how to do this without having to check for neighbors for every packet you forward. You can kind of pre-calculate which interfaces to forward the messages on. Yeah, I think that's about it. There's some hello option to indicate that you support this. And yeah, I just said this. So yeah, my plan is to implement the sub-TLV part as well. There's want to have some logic to detect if your neighbor supports it, and if it doesn't, then you can kind of downgrade to using the old TLV but stripping the sub-TLVs. So I want to implement that part and do some more testing, but otherwise I think it should be done from my side soon. So I'll give you another update next IETF. Any comments? Welcome. Yeah. Okay. Thanks.
Thank you. All right, Nate, I'm pulling up your slides and I'll give you slide control.
All right, good afternoon, everybody. So today we're going to talk about 4 documents. I'll summarize that in the next page here, but a lot to go over and just about 10 minutes to do that. Here we go, I got control, thank you. All right, so we have 4 documents here. The first one is past the working group last call, and that's the problem statement document. Lists out the problem statement and requirements and the criteria for evaluating proposed solutions. The second document is a proposed update to the multicast group ID allocation, and the hope is that that'll go to last call soon. There's a zeroconf assignment, which is an NDNS-based zeroconf assignment protocol, and there's also GAP. So those last 2 are solutions to the problem put forth in the problem statement. And the hope is that the last 3 would all go to last call soon. Okay, so diving into the problem statement again, just to refresh everybody. The idea behind this is that the way that we use multicast snooping in marine networks is that we have a lot of different multicast streams there coming from radar sources, sonar sources, video streams, and so on. Each data stream is assigned a different multicast address, and devices are only going to request streams that they're interested in or can handle. And then the multicast snooping switch will forward packets only to the interested ports. And this becomes important when you have mixed link speeds here. So for example, this gigabit radar could saturate the link between the switch and the, I think that's a heading sensor there. It could saturate the link there if that's only 100 megabit link. So that's why we use a managed switch and multicast snooping to prevent that traffic from going out there. But the displays can still request that data. The problem is when you start to mix in multiple different types of sensors, more than one radar, more than one sonar, the pre-allocated way of assigning addresses doesn't lend itself well to flexibility in the networks. So to understand that better, we want to move towards something like a dynamic multicast assignment. But there's some challenges with that. And so just kind of an overview here of the multicast addresses and what they're composed of. RC 1884, that's the format there. You got 112 bits for the group ID. And then RC 2464 talks about how you transmit IPv6 packets over Ethernet networks, and you basically take, for your 48-bit MAC address, you take the first 2 octets and set it to 3333, and then the last 4 are the last 4 octets of the IPv6 multicast address. RFC 3307 has guidance that basically says group IDs less than or equal to 32 bits long will generate unique link layer addresses within a given multicast scope. But this does present a problem when you're transmitting on Ethernet. For example, you have the link scoped IPv6 multicast address where each node can basically assign its own multicast addresses. They'll have a unique IID, but then the group ID there is chosen either randomly or maybe they might just start at 0 and start allocating new addresses from there. But in any case, when you go to transmit that onto Ethernet, the 32-bit group ID combined with the 3333 will result in duplicate MAC addresses. And that causes problems with managed switches that focus only on the MAC address for how they're going to manage their address tables. So we considered a number of solutions here to address the problem. You could have the switch pay attention to the IPv6 destination address, and so you're considering the full 120 bits of that address. But the RFC 4541, which is the multicast snooping RFC, basically indicates that most switch vendors do not support that. We looked at source-specific multicast, but that's not universally supported by switch hardware, and definitely it's designed more for routing for traffic between networks than it is locally. MADCAP is a centralized mechanism for assigning IP addresses, multicast IP addresses. But the problem within a marine network is that it represents a single point of failure. So if we ever lose contact with that MADCAP server, or if the device goes offline, then you lose that and basically take out any sort of sensor that is reliant on that dynamic address allocation. ZMAP is a decentralized mechanism, but that was never published. The draft expired in 2003. We looked at maybe bringing that back to life, but ultimately decided that there would be better options by kind of starting over. So ultimately what we decided was that the solution is a decentralized zero configuration protocol for dynamically assigning multicast addresses. The requirements for this solution are that it does not does not rely on a single point of failure, does not depend on user configuration, coexists with other multicast address assignment protocols, supports operation on a single subnet, does not require an internet connection, supports multiple applications on the same host, and detects and resolves address collisions. So before we get into the solutions here, we have to take a bit of a detour and talk about how multicast group IDs are currently allocated. So RFC 3307 lays out the multicast address guidelines, where they define a group ID is there's three different ranges here. You've got the permanent IPv6 multicast addresses, and those are allocated by IANA. You've also got group identifiers allocated by IANA. So those are going to be your hex 1 through 7F, FFF, etc. Then section 4.3 talks about dynamic IPv6 multicast addresses, and that's for hex 80 through FF. But the problem is it does define both server allocation and host allocation mechanisms for that, but the ranges overlap. So if you were to lay this out on a table, we'll see that the server allocation and the host allocation conflict with each other. And then there's also the solicited node multicast addresses that are used for neighbor discovery protocol, and that conflicts with that range as well. So in order to resolve that, we propose that IANA have a new table for allocating the multicast addresses in the dynamic assignment range. And this is what it would currently look like with the protocols that are currently published. Now, that first entry from MADCAP, that would be a revision on its current allocated range, that we would cut that down a bit and to leave a large unassigned area. And then, of course, the solicited node multicast addresses would get in there as well. And then our hope is that eventually, once we publish the solution documents, that we would have two more entries in this table, one for the zero configuration algorithm and one for the group for GAP. Okay, so getting onto the assignment protocols, these are the solutions that we came up with. Both of these protocols meet the requirements on the problem statement. So then the question is, well, why do we need two of them? The zeroconf algorithm is built on MDNS, which means that we might be able to take advantage of existing software out there. It works by choosing a random address and publishes a PTR record in a new ethaddr.arper range, or special purpose domain, and then it retains that address for future use, which ensures that the network eventually reaches a steady state. But it is IPv6 only. The GAP protocol is a new protocol. It calculates the address from the hash of a group name, and it supports IPv4 as well as IPv6. So moving forward, we're hoping to get working group last call for those three documents. And then brief note, in Ireland, we presented, and in Bangkok as well, we presented on progress on a multicast snooping optimization. That's the name of the document up there. And I just wanted to apologize to our colleagues at Juniper for the delay on that. We intend to resume that before too much longer. Okay, thanks for your attention. Are there any questions?
Yeah, this is Stig. So yeah, you have two solutions, and you said a little bit about why two. But if let's say someone reads these RFCs later and they wonder which one should they use, which one should they implement, or whatever, is there any recommendations so people can kind of choose what works best for them, or?
I think it kind of depends. If you only need IPv6 and you happen to already be using IP or MDNS within your network design, then the zeroconf one is better. If you need IPv4, then the GAP one, that's the only one that supports IPv4.
Right. So yeah, so at least I think, well, one thing is the ISG might possibly ask, why are we coming with two solutions? So it would be good to have some more details on that, I feel. And yeah, the other thing is for users to choose. And yeah, it can be more or less what you just said, but I think it's good to at least explain that to some extent. So apart from the v4, v6 part, is the retaining the addresses maybe one of the big benefits of the MDNS, or?
I think that's just how it handles the situation for
Yeah.
you don't want to have to renegotiate addresses every time you start the network up. I think GAP handles that a little differently in that because it's using the hash of a group name, it inherently kind of retains that anyway. And then I guess for our use case, we're representing a standards body. And so within that, area of concern, the standard body would choose, okay, this is what we're going to be using for marine networks. But then other deployments may have different opinions on what's going to work best for them.
Yeah. Yeah, at least it's good if you can give it some thought if there's some more text that could be added to explain this a bit.
Okay, yeah, we can work that out with the authors.
Yeah.
But aside from that,
yeah, that's the only concern I have, at least. Yeah.
Yeah, this is Mike. I think that's valid. We could maybe figure out where in each of the drafts we can put the similar wording in referencing the other solution and why you may want to choose one over the other. It would be pretty simple to do. The question we have, Stig, is I can't remember how we've done this before, but we have 3 drafts here that are queued up for working group class call. We're going to have to decide whether we just do them all at the same time or do we just do one after the other. And you're going to have to do it.
Yeah.
So.
Yeah, I don't think it matters that much with the order, but I think it makes sense to me to do the solutions maybe together during the same time. The third draft is, about splitting up the ranges. That's kind of like a separate thing that can be done on its own, I think. Should we do a poll or something, or I don't know.
I don't know what to say in the poll.
Yeah. Well, basically, I wonder if the working group thinks these drafts are ready for last call. But I can ask differently. Is there anyone here in the room or remotely that have any concerns about taking these to last call?
Start a poll just to do it.
Let's see the poll. Oh.
Oh, yeah.
I guess I don't have to do this.
We do have somebody in the queue.
Oh, yeah, go ahead.
Well, I didn't check the gap draft, but I think there is some. So I just checked the draft now, and there was some description about hash collision, and maybe there is some solution about if there is hash collision. So how we can guarantee the uniqueness and so on. So, but I'm not sure that this kind of procedure is securely guaranteed, or is there any review by some security specialist and so on, or we don't need to care about such kind of security aspects about such kind of such hash collision? Do you understand what I mean?
Yeah, I think so. I think both of the ZeroConf and the GAP protocols, if you have somebody on the network who wants to disrupt operation, they can certainly put out messages that would do so. You would, in order to secure your data, you would want to encrypt it at the application layer, or use IPsec or something like that. But as far as allocating the multicast addresses, somebody could do a denial of service by just repeatedly putting out collisions. So I think that might be an underlying assumption of both of these.
Okay.
Does that answer the question?
Hi, this is Dino. Nate, let me take a crack at the question. So the spec does provide with hash collision repair. And it turns out that the application that I wrote called GapChat that uses a library that implements the protocol uses encryption. So, and what my implementation also did was it found out if people were trying to collide with different groups. So in other words, if there's two different group names and one of the group names doesn't hash to the first one, but they're using that address, we can take them out of the group. We were trying to figure out a way to move everybody to a new group. So there are some provisions. It may not be totally complete, but have a look at it and let us know.
And I'd add for the MDNS-based one, we kind of look to MDNS if there's a need for encryption or additional protection. That would be solved by the MDNS protocol.
Stig here. So is there any more text needed about collisions in the solution drafts, or is that all good? Sure. Well, looks like there's good support for taking it to last call. Yeah, if you like Hitoshi or anyone else can reach, raise this on the mailing list, or we can also take it as part of the last call feedback and see if there's anything needed to address the collisions.
Thank you, Nate.
Thank you. Have a good day.
Okay, Montemana.
Yeah. Good afternoon, and we are going to talk about PIM backup DR, and we did present it a bunch of time, and there were a lot of confusion about what to do with the DR improvement draft, and there were comment about adding some extra text for stickiness of PIM DR. So after giving a lot of thought, I thought that backup DR and having stickiness behavior, they are kind of disjoint. It doesn't need, it's not necessary that both of them have to be together. So it's better to keep them independent. What we are trying to solve, since we presented it long ago, I'm just trying to kind of refresh the memory. So by default, when PIM DR reelection is happening, it could be because of failure in this picture. If you look at R3, so R3 is a DR right now. And if there is any failure at R3, but it is going to take some amount of time to have reelection plus rebuilding the tree. So you will have transient traffic loss at that point of time. And the second case is if new router comes into the LAN with high priority, the same problem will happen, where the new router will become DR immediately, and it will take some time to really rebuild the tree and start forwarding the traffic. The goal of this draft is how can we reuse the existing PIM spec and still minimize the traffic loss during re-election, and keep the simplicity what PIM is providing rather than coming up with too many extra protocol extension. So there are two things which we are going to talk about. The first thing is having a backup DR, and the second thing is delayed DR election. So if you look at both of the point, it's not necessary that you have to really have delayed DR election. It really depends on what deployment is trying to achieve. So the first part, the backup DR election procedure is exactly same what your PIM DR election procedure is. So what we are going to do that instead of having just one DR in the network, you elect a second DR which becomes a backup DR, and it can build a traffic, it can build a upstream tree, but it will not forward the traffic, and the traffic will be forwarded only when it detects the primary DR is out of the network. So the the benefit which you will get out of this is backup DR can resume as soon as it detects that the DR is out of the network. The second case which we are speaking about is delayed DR election. The reason is, irrespective of even if you have backup DR, let's say that what if some new router comes which has priority of 500. In the previous picture, we had priority of 100, 200, 300, and 400. So when priority of 500 comes into the network, it is going to immediately really do the DR re-election, and it will start taking over the tree, and you will have transient traffic loss. So this draft defines that if deployment really wants to minimize traffic loss, even in that case, what it can do, it can initiate it can delay the DR election, where you start sending your DR priority as a 0, and you still send your actual DR priority, that what your new DR priority will be. And there are a few cases possible where either you can be the new DR, or maybe you are not DR at all. So if you are not DR at all, you don't need to worry about it.
But if you are a DR, you say that this is my original priority, but when I'm sending DR priority 0, it means you don't want others to really give up their DR role yet, so that you get time to build your upstream tree. So if you look at this picture, maybe it will be easy with picture. In this picture, when R4 comes up, R4 is going to send its priority as a 0. At the same time, it says that my configured priority is 400. What it means for R1, R2, R3, that R3 knows that there is a new DR coming, but there is no election happening yet, because R3 is considering priority 0 for R4. While R4 builds its own tree, upstream tree, but it is not forwarding yet. And once the timer has expired, it will start sending its original priority, and that's when DR reelection will kick in. You already have pre-built the tree, so that will make it easy. You'll have minimum traffic loss. Sure.
This is Dino. So when the new router comes up and joins the tree, duplicates will come to the land, or
No,
does the new DR does R4 not forward packets?
it does not forward.
Okay.
And another case can happen that, let's say that while R4 is really building the tree, at the same time R5 comes, and R5 has a priority of 500. Even though it is sending its priority as a 0, but the configured priority is 500. So R4 is really going to prune its tree. It knows that it is not going to be DR anymore. So it is kind of, it really depends that in the worst case, if your network, each router is coming after a few seconds, there are chances that you might end up building multiple trees and keep pruning it. But by and large, or in real deployment scenario, we don't expect these type of scenario to happen. So it will be okay.
Yeah, a comment, Stig here. Yeah, so I think there are implementations from some vendors that do this delayed DR election today, where they don't immediately, take over SDR. But I don't know if they have a hello option like this.
Sure.
So the reason for the hello option is to avoid multiple new routers trying
Exactly.
to join the tree,
Yes.
I guess.
Yeah.
Yeah.
So if you don't have hello options, what will happen if there are 400, 500, 600 priority coming in? Of all of them start sending as a 0, and all of them, they only know about their priority plus 3 other priorities. So they have no clue that after re-election who is exactly going to be DR. So that will kind of cause 3 trees to be built in advance. So it's better to kind of give a hint that this is the configured priority. And so this draft adds one extension to hello option where we are going to have delayed DR priority. So when we say delayed DR priority, what it means that you're going to send your original priority as a 0, but you want to still send or notify your peer that what exactly priority is configured, so that you can make the adjustment. So the next step for draft is, I think it is, now we have really trimmed it down. We have made it lightweight, and it is, I don't see any problem it working with existing network. So we'll wait for some more feedback before going to the next step. Yes.
Himanshu from Siena. I haven't read your draft, so it's an offhand comment. How about if, because this is a new and now the legacy boxes has to do something extra for for the delay and all that, why not just the new router refrain from sending because he knows about all other priority, right? So he can just refrain, let the tree build, and then once the tree is built, he would then become the DR.
So if there is only one router coming, yes, this logic will work. If there are 2 routers coming up, and
They all
both
do
of
that.
them,
All of them can do that because they will know everyone's priority, right?
they will not know each other. So let's say,
The 2 new routers
Exactly.
will not know each
Yes.
other. Yeah.
it can work. I won't say that it won't work. Yes, you can go ahead with the logic where each router will independently build the tree. So you might end up having, let's say that 4 routers coming up together. You may create 4 trees, and then you will be pruning
Then
all of them.
and refrain from sending
Exactly.
Yeah. Something to think about.
Sanity, I just confused with the two draft. One is adopted draft, which is BDR right, and the other one is a new individual draft. So I read the two drafts. It seems like this solution is up as in the individual draft, right?
Yes. So backup DR is adopted draft. There was a comment to add stickiness behavior where if we want to support PIM, sticky PIM DR, where once you have DR election done, you want to keep your DR up and running irrespective of whether what is the priority for new router. But I don't see that these two things really need to be together. I mean to say that practically you can have stickiness behavior without having backup DR. So both are independent thing. So I removed the stickiness behavior completely in the independent draft. But if working group thinks that these three things have to be in single draft, we can merge it.
So if it's of the two as are merged, so the in the BDR draft there is two solution here. One is a sticky solution, and the other one is non-sticky solution.
So
right?
stickiness behavior for PIM DR has nothing to do with backup DR. So today we support sticky DR behavior in multiple vendors. Actually, I was looking at the config. So Nokia, Juniper, and Cisco, all three of us support stickiness behavior, but we are not. Our all operating system may not support backup DR. So both are completely distinct solution. I mean, when I say they are different problem space altogether, they are not solving the same problem.
Okay, because I think this problem has existed so long time, so there is many solution for it. So how we will do for these solutions? We just adopt one to publish one, or we can publish all of them. Yeah.
Okay, so let me rephrase my statement. When we are going with backup DR, you are creating live tree. You are waiting to detect the DR failure so that you can forward the traffic. So this is your backup DR solution. Stickiness behavior is you have a single DR, single tree. Even if new router comes, no matter what is the priority, you don't want to give up the DR role.
Yes.
So these two things are completely orthogonal to each other. They can coexist in same network. You can have DR, BDR, and stickiness, but you can have stickiness without having backup DR.
Yes, for the sticky solution, that means the DR will not change even if some routers joins with higher priority.
That's correct.
Right. Yes. So, and we think that in the PIM DR improvement draft, which was adopted several years ago, it is also a sticky solution. So, we just a question to chairs if all of them can be published or something else. Yes. But I support this solution too, because this seems like it's existed solution for years. We know that because from some feedback from our customer, yes, they may choose different solutions for them.
Right.
Yeah.
So the DR improvement draft that does both sticky and backup DR, right?
Yes, sticky. Yes, the solution in PIM DR improvement is sticky solution. Even if some router with higher priority joins in, he will know which one is DR.
But
So
is it also backup DR?
a backup DR will follow will be elected as the highest priority router in the network. Yes. So if the DR fails, the DF fails, the BDR will replace with the highest priority, maybe.
Yeah. Okay. But at least I would say, just like we discussed on the previous presentations, we have two different solutions, and we need to think about, do we want to publish both? Is there a need for both? If you do that, should we have some recommendations for which one to use, or do we just ship them both and just let people do whatever they want?
Okay, thank you.
I'll be real quick. I think if you just delay the DR election, you don't need a backup, and you don't need an extra hello, because just like that the gentleman said is you could wait for all the so the DR comes up, he knows his priority. He will be the DR if his priority is higher than everybody else. He listens to all the hellos. If he isn't the highest priority, then it just operates like today. If he is the highest priority, he's still sending his hellos because he wants everybody else to see it. Everybody else sees this higher priority guy, but they delay it, right? They arguably they may not even have to delay it because when the guy comes up and he knows he's the highest priority, he could start sending joins and wait for traffic to come, and then everybody should then the old DR. You need a timer because you want the old DR to be able to prune the traffic. But I don't think you need a hello because you're just predicting what's happening. The hello just tells you what the DR priority is going to be in the future, not the one he's currently sending the hello with.
That's correct.
But you don't have to do it. So I just think if you put in a timer and use the regular DR election, you're done.
Sure.
The only thing you have to do extra is the new DR has to join. That's what you've already said. And the old one has to prune. But I think that handles all the cases, no?
It will. So the purpose of backup DR is not only to handle the new DRs coming to the network.
Mm-hmm.
So if you have existing network with R1, R2, and R3,
Mhm.
R3 is my DR.
Mhm.
If R3 goes down, R2 needs time to rebuild the tree. So the purpose of backup DR is to really minimize the traffic loss in case of the actual DR failure. So that is case one.
So you could have two DRs in the same
Exactly.
case,
Yes.
but the one just doesn't forward.
That's correct.
Is
Yes.
that what the backup?
Yes.
The definition of backup
Yes.
DR?
Yes.
Okay.
And absolutely correct about your other comment that if we really delay based on timer, we can potentially achieve the same thing what we are doing with hello.
Yeah, and then the new guy coming up doesn't have to send 0.
Yes.
And then he doesn't have to have so much state change.
Yeah.
And eliminating a message is always good, right?
Sure.
Yeah.
Yeah, the only problem is if multiple routers come up at the same time, they both think they are going to be the new best DR.
But they're all going to join.
Yeah, because let's say there is one router with priority 1,
Just
then
put 2 timers in there.
two routers.
Put in a short timer. Then when that timer expires, you do the join, and then when the other timer expires, then you give yourself enough time for everything. So there's a DR election timer and there's a join timer, and the join timer is there because you're waiting for a while before you decide to send the joins.
It can be done. So actually you can either go timer way. So it is possible.
Yeah.
There may be some transient or very corner cases where 2 people may end up joining, but I think that should be okay.
Because they both, that'll only happen if they don't see each other's hellos.
Yeah.
Right.
Yeah.
But if they do, they know which one should and shouldn't. Right?
That's correct. Oh, I thought he has comment.
Yeah, same with me.
Okay.
Yeah, thank you. So Sandy, Chat GPT is a beautiful thing because I just did a quick search on show me in the PIM mailing list a discussion about this because I remember we discussed this very thing. And so back in 22, it came right up. It's just amazing. But you did respond to my request about comparing the 2 drafts, and then you said that they were significantly different and then a detailed comparison would be coming. So what I'd recommend you do with your draft is it's expired, so you should probably update it. We could still use a detailed comparison between these 2 drafts. To Stig's comment about we're happy to propose 2 solutions to the ISG, but it would be helpful either in the draft or in some other mechanism showing what the differences are between them and why we have 2 different solutions. If you're interested in that, then we're happy to progress it.
Okay, it's good because for the 2 solutions, one is need a new hello options, yes, and the other one need a new priority process, yes. So I think that for the software, the update is all needed. Both of the solution needed the software updated, right? So I think that we can make them all existed. Maybe it's one way, and the other solution maybe mix them together or
Okay,
something else.
just
Yeah.
let us know what you want to do.
Okay.
Yeah, so it would be great if we say next IETF could have a bit longer slot that where we can, have like pro and cons and each of the solutions, or proponents of each draft can say why they think, their draft is needed, or
All right, Toshi. Here you go.
Okay, so this is a presentation about ModPass support for IGMP MRD proxy, and actually you have three relevant drafts. And so today I'd like to ask you about the next step for these drafts. So, well, I can skip the background because it's already known that the current IGMP the proxy definition, RFC 4605 doesn't support much forming situations. So we definitely need to support some function of this mechanism. So we have three relevant drafts. One is static upstream interface configuration for proxy, and this is approved as a working group draft, and the intended status is informational. And the second one is dynamic upstream interface configuration using IGMP MLD extension that is defined in RFC 9279. And the last one is a young model to include this kind of new extension. So this supports SDN-like controller-based upstream interface configurations. So I'd like to briefly explain each draft. And the static upstream interface configuration we approved as a working group draft, but there was some question about the subscriber-based upstream interface selection. Especially, we defined this function in a previous version of this draft, but especially for the IPv6, it's mostly impossible to provide subscriber-based authentication based on the link local address. So we should definitely remove this function. Maybe this kind of function must be defined if we need. We must define the new, let's say something like IGMP security implementation maybe. So this is not the main task of this draft. So we can simply remove subscriber-based upstream interface selection. So now we have two major configuration. One is channel-based upstream interface selection, and the other is interface priority-based configuration. And yeah, we can use the default upstream interface if there is no configuration or long configuration. So the next one is a dynamic upstream interface configuration based on the RFC 9278. So we can just simply use this extension field of IGMP MRD. So the upstream, the proxy can decide based on this kind of information, then the dynamically set up the upstream interface. The last one is controller-based upstream interface configuration based on the Young model. So we will augmentation. We will have some augmentation of existing Young data models definition. That is RC 9398. So the main question of this presentation is that we would like to merge the signaling draft. Signaling draft means a dynamic configuration draft into the static configuration working group draft. So and maybe Young model draft can be kept as a separate draft, but the two drafts can be merged into one draft. So I'd like to ask you that this kind of situation is possible So at first, maybe I should ask you to review the signaling draft because this is still individual draft. So the question is, can we submit a merged draft whose intended state is changed to proposed standard before the next IETF, or do we need to confirm it in a mailing list after the your review, or do we need to discuss that kind of situation in a next IETF meeting? So again, the question for everyone is whether we can change the current intended status from informational to proposed standard, and whether it's possible to include merge two drafts or not. So this is a question to all participants. Okay, that's all.
So just to confirm, you're proposing the details in a individual draft be merged into a adopted working group draft.
Yes, yes.
So we would either need to adopt that individual draft or at least decide as a working group if the details in that individual draft are. Yeah, okay. I think we can handle that on the list. Yeah, I think we could ask the list.
Okay.
Like,
Okay,
we
good.
can just, yeah, does that make sense? We can just see if those.
Yeah, at least normally, if you have a working group draft, normally there's nothing stopping authors from really adding new content as they like, and
But we should agree as a working.
yeah, but the working group can, change, ask for it to be changed or taken out or something if they don't like it. But since it's already written down as a draft, it's good to get some input first before it gets added.
Okay. Okay. Good.
But one question I have, at least about the signaling, I know I mentioned this before, but how does the host or the stack know which identifier to use? Is it passed somehow from the application through the stack, or does the admin whatever configure the host somehow with what ID to pass, or?
Well, the IGMP MLD must, currently be implemented in a kernel stack. So application may do some signal to the kernel, and then kernel must form the extension field to IGMP MLD packet and then send to the upstream. So, it's a little bit heavy task to implement that one, but the RFC, what I said, I forgot the number, but our extension draft already support that kind of extension field. So we can just reuse that extension field. So maybe we can assume that that kind of extension field can be supported by the kernel or application, and so we just use the existing RFC
So what you
specification.
would like ideally is that some of the user or the application is able to choose.
Yeah.
Then the question is, I don't know. Yeah, you need to somehow know that, okay, this choice corresponds to this ID or something, but yeah. Okay. The other question I had is what if two hosts are asking for different interfaces or different IDs, right?
Maybe we should describe this kind of a situation in the draft. Yeah.
It's almost like the joint attribute conflict that we will talk about later.
Right.
Yeah. Well, okay. We'll take it to the list and see if people are okay with the merge, I think.
And my question is actually, the reason why we are now thinking about merging the draft is that in a previous meeting, there was a question about the main aim of the static configuration to be an RFC, because it's just informational and it's something like a guideline, because there is no wired format change. So that kind of situation may be a little bit weaker to push it as an RFC. So, this is something like our background to think about
Right.
merging the draft. So maybe having the integrating the signaling draft into the current one is more stronger to push
Right.
the
Yeah.
it to be RFC.
Right.
So
Yeah. By the way, when you merge this, both of them will be optional, right? Someone can choose to implement either just the static or just the
sure,
dynamic.
sure,
I
sure,
guess. Yeah,
sure.
yeah. But no, I get your point. Yeah.
Yeah, but
Yeah.
so if the chair or members think that still keeping the static configuration draft is better, then we can of course go without merging the draft.
What do you prefer?
What we prefer? I don't know.
Okay.
To because well, again, the maybe just making a guideline RFC is really difficult. Maybe Brian has some comment about, because previously, so well, sorry for the long discussion, but the reason why the explicit tracking draft, that was really, really important, and but it was failed by the ISD review last time, and because there was no wire format change. So even though the other function is really important, if there is no wire format change, why we need to have RFC? Maybe when Brian was ISG, so there were such kind of comment. So maybe the situation is really similar. So I think it's better to merge the draft and yeah, having the proposed standard draft RFC is better or easier.
I would express support for merging. These are two pretty similar things. Why not put them in one? There's seems like a no-brainer. I would give a thumbs up.
Yeah, yeah. No, yeah, personally, I agree. I think it's good that you can choose to implement just one of them if you want, but personally, I feel it can be one document. Yeah.
Okay, I'll wait your comment.
Yeah.
Okay, thank you.
Appreciate it.
Yeah.
All right, back to you, Montemana.
Thomas asked to be moved a bit, or is he still?
He wants us to be just swap these two.
Oh, okay. I see.
Let's see. What are we at? What are we on here? Sticky.
Yeah.
Oh, Lenny, you have question before I start?
Oh, no.
Okay.
Oh, sorry. Yeah,
Whose fault is that?
That's my
Yeah, it's because of new feature which I'm going to present. So this particular draft, if we see, so before in fact writing the draft, I was kind of looking into what we support. So I know that Cisco does support this. I looked at some of the Juniper config. Juniper also has something similar which is already present. Nokia also has such configuration. So just wanted to bring it here so that we can have it kind of really make it standard, and if anyone else is trying to support sticky PIM DR, so they can have this same way. Very simple problem statement that there are deployments where if I have 3 routers in my network, irrespective of what is the priority coming for the 4th router, I don't want to give up the DR role. And it could be very simple reason that you really don't want that transient traffic loss. And in such cases, you want to have, once DR election is done, let it be there unless that router fails. Or maybe once in a while, for some practical reason, as an operator, you want to enforce re-election. So this particular draft is talking about these two cases, that how we are going to support both cases. The solution, it is, this is how it has been in fact implemented in XR, something close with other vendors as well. So the solution says that we have our DR election as the way we are doing it today, and it is kind of a giving a mutex value so that nobody else can really take it over. So what we are going to do that assign a max DR priority -1 to the elected DR, and after this step R3 is always going to announce its DR priority as a max DR priority -1. What this will result into that no matter who is coming or any new router is coming, it is not going to take over. And when new router comes up, even if router R4 gets priority 400, definitely it will not take over. Now the question comes, what if someone really goes and configures this max -1 as a configured priority? You can, it is kind of, you have multiple ways to mess up your network, so this will be one of them. We can't prevent in that case. And as I said that, what if you have backup DR also configured? So in that case we are saying that the backup DR can get the priority of max -2, but there are multiple variations possible here, and I really, okay, even though I have put it here, but while I was thinking I thought it may not be needed, because backup DR stickiness behavior, I don't see the reason that if you really want to have a backup DR, why do you want to have a stickiness behavior? But if some customer wants, yes, this is how we will do it. Otherwise backup DR can do its own re-election.
I don't think you need any of this because you already have a sticky DR. It's the one with the highest priority,
No, but which one?
the first part.
Yes. So this is not needed, just for the sake of completion, that in case you want to have stickiness.
I don't think a sticky DR new solution is necessary because we already have one. When you bring up all the routers, the network administrator decided what the priority was. And the one with the highest priority is a sticky DR. Any new router that comes up should not have a higher priority. That's a network management problem.
No, that is not true. So let's go into this picture. So I have R1, R2, R3. R3 is DR. R3 failed. R3, there was a router got reloaded. Now when R3 comes up, R3 will come with priority 300, but there are deployments where you don't want to move the traffic back to 300 even if the configured priority is 300. So
if you want one particular router to be sticky and always have the traffic, it's the highest priority one by definition.
Yeah. Yes, that's correct. So there are actually deployments where
I think it's over engineering a problem that doesn't happen that often. It's adding all this extra machinery that makes the implementation complicated. Well, routers don't crash that often. You have to handle it, but they don't crash that often to have all this machinery put in.
it is deployed, by the way, and it was us.
It doesn't matter.
Yes.
Just because you can do it doesn't mean you should do it.
Yeah, Jeffrey Zhang, HPE. I haven't really thought through about this yet, but it just reminds me of OSPF, DR, and my impression is that they have the stickiness there. The OSPF, DR, the existing one, they don't get preempted. I wonder. I hope I'm not wrong, but I don't know if the same mechanism should be used here. If they already have the stickiness.
When we designed PIM originally, it's the same as OSPF, but the OSPF has a simpler issue because it's only for flooding. It's not for data forwarding.
Right, but
here we have to do data forwarding, and that's why everybody's sensitive to the problem.
Right, but I mean that. I guess I need to confirm if OSPF, DR have the stickiness. If they already have the stickiness, then
They do it just with priority. With priority, I claim that stickiness.
I guess I'll try to find offline because somehow I have the impression that that the new router will not mess up the existing ones, even if they right. That may be wrong. I'll confirm it offline. Yeah.
Sunny T, Actually, I agree with Jeffrey because I will check with FC 23, 28. So in my memory, if my memory is right, the in OSPF it's sticky. So the same mechanism is used in PIM improvement draft. So the draft has been adopted years before. So that draft borrows the idea from OSPF. So this idea is not from OSPF. So yeah.
Understood.
Yeah.
But it's a different problem. It's not as severe.
Yeah.
Niels from Deutsche Telekom. I just wanted to reply to one comment of yours saying this does not happen so often, right? As an operator, I have slightly different experience there because there's a lot of disturbances in the network. Point one, point two. It's not just because of failures that router powers down, but there are also something called updates, reloads. This all kind of things you need to restart your router, even though the router vendors promise you that they have in-life upgrades of software. It turns out it often doesn't work. So I do see a point, Mankamana, that there is a problem to solve. Yeah.
But why don't you raise the priority of what is going to be the backup before you take the other one down? You could do that very easily with network management.
Yes, you could do that, but then you would have to have either a controller in place that does it, or the second point, you would have to have very rigid operational plans in place. And I can tell you out of experience, half of the time, it's not going to happen the way that the engineers have planned for it.
Yeah, so I'm in the queue as well here. Sorry, but yeah, so even if you do that, if you do a planned change of the DR priority, that also can cause some traffic loss.
Yes.
But I feel like what you are saying, Dino, is more or less sticky in the sense that you want a specific router to be the DR when everyone is up.
Yeah.
But this stickiness is more like, I don't care which router is DR, but whoever is DR should keep being DR, kind of.
Okay, just to repeat, we have failures and we have recoveries, right? And I don't see why customers need to have two outages, two interruptions in that case. I'm not claiming whether this is the best or the only way to do it, but certainly not one that also requires a controller, right? So, and I think we need a solution for that. And if somebody has a better idea than this to make it half the number of outages, please step forward.
So I just did a Google search, and the AI overview says that if the existing DR or BDR is still active, the new router will not be elected as DR or BDR, even if it has a higher priority. To force a new election, you will need to either shut down the current DR BDR interface or lower its priority. So
Yeah,
it
but
seems that we could borrow the OSPF for implementation.
no, but the PIM RFC says that if any router comes with high priority, you have to give up. That's what the base PIM RFC says.
Yes, because the network administrator wanted that box to be the DR.
Yes.
But if you go with Stick's point, anyone could be the DR. But you have to care which one is it, because there's policy. Usually they all default to 100, right? So.
Sunny ZT, I think the key elements here is that we must use BDR to monitor the status of DR, because when DR fails, there is packet loss. So this is the first point, the elements. And the yes, and the second is if somebody wants to use the one has higher priority to replace the previous one, and or he will add a new element here, a router here. So while he put it in it, he should not influence the DR process. Yes. So if we use function defined in PIM-DR improvement, the router with the highest priority will be elected as BDR. So maybe he will not forward the flow because DR is existed. But when DR fails, he will do it. So yes, so the two goals will be achieved by the function. Yeah, I mentioned. Yeah. Yes.
Because when the highest priority goes away, they'll automatically be.
Yes.
I
Yes.
know you have to pre-join. That's the new problem.
Yes, if the DR has the highest priority here, the BDR will have the second highest priority here. Yes, yes. But if the DR has been elected and it has not the highest priority because somebody with a higher priority joins, they will not give the role to the new router. But one in case the DR fails, it will give the role to the highest to the router with the highest priority. Yes, yeah, that's the solution we that's the solution we introduced in PIM improvement draft. Yeah.
Okay, we're going to move on. Thank you.
So moving on to next draft, this particular draft, few disclaimer. Even though I'm using term SRv6, so there is a nothing SRv6 construct being used here. So it is pure PIM over IPv6. Number one. Number two, this is informational draft. So we are not doing any new protocol extensions. The whole reason why this draft is coming into the existence because a lot of customers, they had confusion about how exactly they're going to deploy or what all the possible solutions if they are migrating their unicast network to SRv6. So there are the use cases which we are going to speak about. I think many of them, it's already present in multiple different places. We are just bringing it together so that it becomes a handy document for customers for deployment. So the first use case is if you have just end-to-end IPv6. So nothing prevents you to turn on PIMv6 end-to-end and run your multicast over low-cast tree, which is running your PIMv6, classic PIMv6 over SRv6 network. The second case which we talk about is if you have FlexAlgo in your network. So there is already existing draft where we are talking about how to support PIM with FlexAlgo. It is, I think, not adopted yet. So it is a individual draft in PIM working group. So SRv6 network with PIM can reuse the same construct where you don't want to really build your tree using your low latency path or potentially you want to go low latency, not the highest IGP path. And you can build your tree per FlexAlgo and your multicast can be serviced over this SRv6 network. The third option which we have is a centralized control plane. And even in this case, if we look at the data plane, so data plane still remains exactly same, which is native IPv6. So your controller, instead of PIM programming the tree, controller is programming the trees around the network. And you get rid of PIM because if you don't want to run PIM, PIM in the network. But if you look at the forwarding state, so forwarding state is going to remain exactly same as native IPv6 multicast forwarding. What what is the extra benefit which centralized control plane provides? It is more flexibility compared to FlexAlgo. So FlexAlgo you may not be able to really define a policies where you can say that I don't want to use this particular link or avoid this particular box. Potentially with centralized control plane, you have more handle over it. The last case is if you want to use multicast over VPN or MVPN cases. So in this case, you can use either of the underlay tree building mechanism, which is your just PIMv6 or with FlexAlgo or centralized TE tree. And you can build those many daytime IPMZ or SPMZ, which we call daytime DT or default MDT trees. And your underlay trees are still going to be built by PIM protocol. So we can use next gen MVPN signaling for customer signaling, whereas your underlay is being built by PIM. The last section, which really I think it is more of implementation and it is important as well, is how exactly data plane encapsulation is going to happen. So your data plane encapsulation for this particular solution is going to be IP in IP, where if you have IPv4 header coming in or IPv4 traffic coming in, so you are going to encapsulate it with v6 header and carry it over the core. So that's all. It's pretty short informational draft, and if there are any comments, so please provide.
So I haven't found the time to read it, sorry, but I do know that Mbondi has adopted what I would feel to be a similar draft in terms of giving some overview, so it might be good to bring this also to Mbondi so that they express an opinion, because I think overall recommendation of how to apply the technologies that we have operationally is primarily been an Mbondi thing. But in any case, it would just look very stupid if the same type of scope was done in one working group document in PIM and the other in Mbondi without getting an overall picture how
Sure.
this all aligns.
That's all.
So just real quick question before you actually get back up here, just real quick. So there's no, as you stated, there's no new protocols that are being proposed. It's probably an informational draft.
Yes.
It's explaining how PIM can be integrated with SRv6 and FlexAlgo and other things to make multicast work
That's correct.
over SRv6.
Yes.
And it's meant to be kind of a maybe not a best use case, but just to be able to answer the question of how multicast can be used in a specifically segment routing v6 or segment routing in general, or
SRv6 or any IPv6
or any
network.
IPv6.
That's correct. Yes.
Okay, thank you.
Niels from Deutsche Telekom again. First of all, thank you for the draft. I think it's very well written. When I came across the draft, I was debating with myself whether it is a good idea also to mention the method of deploying or deploying beer, just as a side reference, so that you give a hint that there's additional protocols that could be used in order to achieve it.
So the reason why we didn't add beer here is there is another draft which Jeffrey has that already talks about how beer can be deployed in that network. So I don't think there's really, it will be kind of redundant.
I understand that. I was just, my thought comes from the point that you're trying to provide an extensive overview of what is possible. So maybe that would be helpful. I don't know.
Thanks.
Thank you.
One more question.
Yeah.
Sunny Zhang, just a question about why TRICID or P2MP policy has not been mentioned in this draft, because I think that it's really the alternative solution for it, and it's also can be used over SRv6. Yeah.
Yeah. So if you look at the draft, it clearly says that how PIM can be deployed. So this actually draft is limited to the scope of draft is if you want to utilize PIM, how exactly it is going to work. So it doesn't say that don't use TRICID, or it doesn't say don't use ingress replication or something else. So there are, of course, there are multiple ways to build the tree. But if you want to use PIM, what exactly or how exactly you are going to carry the traffic over IPv6 core.
Okay, but I think if it's just limited in PIM, and you must mention that the prefix it used from different routing table, because we know that from FlexAlgo, different prefix may be existed in different routing tables. So he must look up the right routing table to get the right next hop. Yeah.
Sure. Thanks.
Oh, okay.
Sorry, can you hear me? Good evening, everyone. Can you hear me?
Yeah.
Okay, thanks. Thanks.
Passing you control.
Okay.
And just speak up a little louder. You're pretty light.
Okay, sure. Is it better now?
Yeah, it's great.
Okay, okay. So good evening, everyone. So this is the BIS draft for the combined RFC 8059, 97, 98. So yeah, basically both of the RFCs 8059 and 97, 98 were experimental. I think 97, 98 just got to RFC, so we thought that this is probably a good time to make the BIS drafts primarily to get them to standards track. And this is probably one of the last few documents in the Lisp multicast section that is undergoing the experimental to standard track this process. The unicast drafts have already been done. The 6831, 6531, I'm sorry, I don't remember the number right, is already being done by Dino and us. So this is probably one of the last ones. Why are they needed? They're primarily, 8059 was brought in essentially to introduce two new join prune attributes for the, PIM TLVs. So essentially join prune attributes for Lisp. The first one is essentially to kind of signal the underlay transport preference that an ETR or a egress Lisp node Lisp site wants to use, whether it's unicast or multicast IPv4 v6, and even potentially a combination of the above as well. If there are multiple transport options that somebody can listen to. Uh, that's the first reason why that attribute was introduced. And then there is something called a receiver RLAC attribute. I mean, none of this is new. These are all introduced in 8059, and of course slightly enhanced by 97, 98. And the receiver RLAC attribute is essentially specifies the multicast group or the unicast RLOC, that a receiver RLOC wants to use for a particular flow. So, given the Lisp signaling, the way it works with the PIM over PIM, the previous one, the SRV6 context, this is the Lisp context, but we found this extremely useful and being implemented, of course, by uh, Cisco IOSXE and being deployed in a lot of places. So we thought that it's very reasonable to bring this to standards track. So that's the reason for the BIS drafts. I don't think I probably have to go to the solution. Yeah, please go ahead.
Yeah, so looks to me more, given how you don't have an update section, as if you're trying to obsolete the two other RFCs. Yes, no?
Yes, we are trying to obsolete the two RFCs.
Yeah, that's a different status. So please change that accordingly.
Sure.
Not updates.
Sure.
Yeah.
Thank you for pointing that out. Thank you for pointing it out. Yeah. So yeah, I think mostly what I covered earlier is essentially the Lisp transport attribute and the receiver ETR RLOC attributes are defined there, and we can pretty much reuse the IANA code points. I think that's one of the doubts I had, and I think Stig clarified that offline. That you can reuse the same IANA code points, but probably update the text. Same point that Carlos brought up. Make sure that we clearly call out that we are obsoleting the two experimental RFCs, and then this is the new standards track RFC that will replace them. We'll probably add text and to that effect, but no real functional change in that sense. We don't want any change because this is pretty much the same content that was already available in experimental track. We're now bringing it to standards track.
Yeah, Stig here, just a comment, and yeah, I'm also an author. Yeah, I think it should use the same code points. It's the same when you progress other drafts, to internet standard or whatever. Because you want existing implementations
Yes.
to actually support the new RFC.
Yes. Yeah, mostly that's it from my side. I don't think I have anything more to add. Stig, anything you want to add? Thank you. Thank you.
Yeah. Oh, okay. Nothing. No requests? Okay, yeah. Very good. Thank you. Yeah.
All right, so in Bangkok, I was presenting a draft on the experiment that we would like to do to bring the stateless multicast forwarding to PIM. Greg, do you want to ask now or wait later? Greg? I can't hear him. He's in the queue. Not sure.
Go ahead, Greg.
Okay.
How's that? Can you hear me now?
Yep.
Okay. Yeah, it seemed that this already in the draft mentions beer and 6 as the standard solution. Why is this not being presented in beer?
Well, the whole point was that you said a solution that reuses the beer architecture but doesn't use the beer encapsulation is not a beer solution. And the IETF has also said that multicast extension to SRv6 are handled in PIM. So that's basically
but this is not encapsulation. This is encoding. You're changing the forwarding plane. So it's not a simple v6 encapsulation.
It is IPv6 encapsulation, right? So one of the options
you're
is
encoding the bits into the header. That's not encapsulated in v6. This discussion began years ago, and we asked you to rename it as encap, and the original author agreed that it was encap, but because of whatever reason, you encode. Excuse me. You continue to call it encapsulation. So
no, wait a second. So okay, for the people to understand this, who may not have been in Bangkok, right? So the experiment draft explains all this history that Greg is talking about, right? So, and I think it's a more process document that doesn't need to become an RFC, but that I was suggesting to adopt in PIM. So to basically
does it explain that this work was rejected by the beer working group?
Yes, of course.
Does it explain that it had 2 BOFs that were rejected as well by the IETF at large?
The BOFs were for they were a working group forming BOF. So that was basically a rejection at this work and talking with ISG. Of course, the answer was take that work to the appropriate working groups like PIM, which I'm doing here.
Okay, so and you're claiming that this doesn't change the forwarding plane. This is just encapsulation.
No, of course it does change the forwarding plane because
okay.
the way that IPv6 packets are handled hop by hop is exactly incompatible with beer, which is why the people who want to have an IPv6 only network cannot work with the.
That's not true. That's beer and 6 is native v6 that allows beer.
No, it is a solution that tunnels across IPv6, but it is not a native IPv6 solution.
Link local is not tunneling. That's just
that is still a tunnel. That is still a tunnel.
And,
right,
and how is so that's the layered architecture that the IETF has put forward and has been dominant in the internet
this
for
is
decades.
The solution of one particular working group that uses hop by hop forwarding based on a particular beer header, right? It is a layer 2.5 solution. It's all in the experiment document, right? So this is a native IPv6 solution using an IPv6 routing extension header, which is a much more preferred solution by IPv6 network operators.
Well, that's an opinion. There's no proof of that since the v6 group
but that's basically
beer for our input.
But that's basically exactly why we have a rough consensus process, right? So if there are sufficiently many operators that are interested in having this work adopted, then we can basically figure out if the PIM working group is the right group to adopt this.
To adopt this rejected work.
In beer rejected work. Right?
In the
so
forwarding
beer, because in beer you ran a very tricky process of eliminating any operational considerations for requirements and took it down purely to functional things. And hop by hop tunneling over link local scope IPv6 tunnel, which aren't working on any bloody router, right? Is not a good solution for IPv6 networks. Sorry, this is part of the experiment document, and I would like to continue to talk about the new draft that I've written.
I just want to make sure everyone understands that this work has been rejected by beer and has presented in 2 BOFs that were rejected.
Okay, first of all, this is not exactly the same type of encapsulation, same type of features that was discussed 2 years ago in the MSR6 BOF, this has evolved since then, and I think there are very clear differences visible in what this is versus what beer is trying to do.
So let me just make one more point then to make sure that when beer was formed, AD at the time made sure that we understood that we're talking about the forwarding plane. It's the narrow part of the hourglass. She insisted that we took our time, collaborated with everyone across the IETF, and got it right. And once we standardized it, we defended it, because having options in the forwarding plane complicates the layered structure of the internet.
So which is why for IPv6 networks in unicast we already have 1, 2, 3, 4. I can go to that slide. So here is basically what we have for IPv6 unicast forwarding in last service provider networks, kind of all RFC 8200 stateless solution forwardings, right? So we started out with the SRH header, which is kind of the traditional uncompressed unicast hop-by-hop forwarding. And then basically there is also the same equivalent for IoT networks, which is RFC 6554. And then there is basically 2 different encodings with a 6-man experimental draft from Juniper, CRH 16 and CRH 32. And then there are also 2 different type of encodings of compressed forwarding sequences for unicast forwarding that also uses the SRH header, right? So 1, 2, 3, 4, 5, 6 different forms of doing stateless forwarding with steering in unicast. And you're not telling me that options exist in the IETF because we have different preferences in different customer spaces. And again, if you're neglecting that the same is true for multicast, I think that is ridiculous. So
no, I think it's ridiculous to think that V6 extension headers should be used to replicate every forwarding function that the IETF has already standardized. Those are new functions, which is the point of the V6 extension header. Add functionality that's unique, so not replicate every function that we already have standardized somewhere else.
Yeah, we got your individual contributor opinion. That's fine. So that's why we have rough consensus process, right? Okay, so solution overview. So what I wrote since last time is the draft that specifies the forwarding behavior. So this is called, sorry, exactly here on this last draft IETF PIM Eckert MRH. And I just quickly wanted to show what this does in the forwarding plane. So you basically got an IPv6 packet that is forwarded end-to-end across an IPv6 network with replication, with steering potentially, that is replacing the need for stateful forwarding in the IPv6 network. It doesn't use any form of additional tunneling or so. It's in the same way as any of the different unicast steering headers. So the way that these things work in IPv6 is that you do have the destination address in the IPv6 header that is rewritten on every loose hop of the steering, right? It doesn't have to be a strict hop, it can be a loose hop. And then basically the extension header has 2 elements in there. One is what I call the MSER segment, which is the multicast exit router segment, which is effectively the IPv6 multicast destination address, right? So this is an IPv6 multicast packet with an IPv6 multicast address, source address in the IPv6 header, destination address in the extension header. And then there is, depending on the subtype that we're using, where I'm thinking we do require 2 different types. One is destination-based, which is kind of really just indicating the replication. The other is steering-based. So for the destination-based, that's exactly where it is using the RFC 8279 forwarding rules, beer exactly with a bit string, with a BSL, SD, and SI as defined in that, right? So this is basically ultimately the option that would make the full IPv6 header with the extension header replacing the beer header, right? So we're using beer forwarding architecture, we're just using a different header. And of course, the draft described the hop-by-hop forwarding rules, where in the same way as in unicast, the IPv6 destination address is rewritten. And then the steering one, that's where we have currently different alternative options. Some of them have been validated through experimental implementations in vendors or in universities. And that one, we're still working out how to come up with a coalesced proposal detail. So that's pretty much what this is. As far as the overall architecture is concerned, That's the next thing. And that's basically shown here a little bit kind of how this would look like, right? You get your IPv6 and with the MRH extension header module in the IPv6 forwarding in the host, in the IPv6 host, and in the routers, and then you have your sender and receiver applications that are just doing normal IPv6 multicast sockets, and then you have your signaling daemon. So the signaling that we were thinking of for that is simply MLD based from the receiver to the sender nodes and then the state table, and it's being translated. So that's for things to come. So yeah, anybody else questions, opinions on that? And the slide with the different IPv6 things that have been done now also kind of discusses exactly what particular implementation choices in the header would mean for which group this would go to, right? So if, for example, we use a new routing header code point type, that would mean that the forwarding plane draft would go to 6-man in the same way as the Juniper draft went. If we're using the SRH routing header code point, then it would be something that would have to be done in agreement between Spring and PIM. So kind of Spring would have to tell us, yes, they're fine that we're overloading this code point like they have overloaded 3 times already, right? So there's the uncompressed, there are the 2 different compression headers, so we can add this one as well. So that's one of the forwarding plane options to decide upon. But obviously the control plane, the architecture, these things of course belong into PIM as IPv6 multicast routing in a stateless fashion for SRv6 networks. Okay.
Get your other working group.
Yeah, thank you.
All right. All right. Yeah, just a second here. Try to find it. What's it called? Yeah. Oh, this is it right there. Yeah.
Hello, everyone. I'm Yisung Liu from Chen Mobile, and today I will introduce the IP vector conflict resolution. In this fig, we have 2 receivers, R1 and R2. So when R1 send the PIM join, when the PIM join come to the R3 router, R3 router assume that R3 router has the MOFR, and it will continue to join join in the primary path to the R2 router, and the backup in the figure with the blue line, the backup join will carry the vector R5, and another receiver R2 will join with the green line in here, and it will send the join from R8 router to the R6 router. So in the R6 router, we have 2 conflicted PIM join. One will take the PIM IPF vector, the R5, and the other join without vector. So how to choose the next RPF? So for the existing RFC, for the RFC 5384, in the PIM join, when we have the same join attributes, that means the type is the same. So we will compare the neighbor address. If the address is the same, we will compare the interface index. But the condition, we must another condition that the join attributes is the same. In the RC 7891, when the PIM join with the IPv vector, but the router must verify the consistent order of the IPv vector types. If the order is inconsistent and the types are considered equal, so the rules along with the RFC 5384 rules. But neither of these RFCs cover the scenario in the previous slide. So in our draft, we recommend new handle mechanism, but we don't think the solution is the best solution. We can discuss. If the first rule is that if one join with the RPF vector and the other without, and we select the join method without the RPF vector. The second rule is that if the PIM join contains one join can only contains the class 0. The class 0 as the original RPF vector, and the other one contains the class 4, that the explicit RPF vector. So we recommend that the join method with the only class 0 get the priority. So under the mechanism we have provided in the previous slide scenario, the join carried the vector R5. Oh, this is something wrong here. Vector R5 on will stop at the R6 router, and the join from R8 to R6 will continue to join hop one by one. So that's our proposal for this problem. So that's all.
Any questions?
Mankamna, Cisco system. So I think problem statement is clear, but for solution we need some more brainstorming. I don't think we can. There are multiple cases to really think about it. Which one to give priority, when to give up, when not to give up.
Okay, thank you.
Yeah, Stig here. Yeah, I'm a little curious. What made you choose the one you did? I mean, there's two options, and but yeah, I also wonder about existing implementations, what they might have done. There must be code today where implementation decide what to do.
Okay.
That's it. Thank you. Well done.
Yeah, finish 2 minutes early.
Hello. Hello.
So on this one is all the way up.
Yeah, that was
a little higher than that.